I would like to step back a little bit and talk about the lab of the future. Very often, one thing is forgotten, which is the data. These are the typical hurdles that we find. And I've included a quote from a customer who said, "We need the freedom to do science." So freeing up time for the scientists to do science, but also freeing the data. When we want to leverage data and to really create higher value, the data must move from, let's say, this isolated state that we have discussed into a state where it can be used for AI and machine learning. One aspect that I would like to mention here is where Tetra Science can help. And this would be the first two steps: collecting the data and engineering the data, building a true foundation for creating the intelligence for decision making.
So I wanted to use this portion of the webinar to give 4 example use cases where customers have leveraged the Scientific Data Cloud to improve and or accelerate scientific workflows. So the first one we'd like to focus on is high throughput screening. What we often see is after that data is acquired, several manual steps. What we find to be the 3 major problems with these types of manual data workflows is, number one, because it's manual transcription, it takes a lot of time. The second problem is it's error prone, so you could end up with data accuracy issues. The third thing is that we often cannot leverage these data for in silico modeling. So what we've been able to do for customers is automate the entirety of the data processing workflow after the scientist hits go on the experiment. So the first 3 steps are really the same. From there, the Scientific Data Cloud will do automatic collection of that data. It will extract metadata from those files. It will harmonize that into a vendor agnostic format. It will then verify and enrich that information from other data from other systems like the compound registry system. And then it will automatically publish that data back to the ELN. And so we were working with a company called Prelude Therapeutics. From an automation perspective, just per run, we were able to save an hour of processing time. But the real outcome here was they were able to increase their screening throughput by 4x in the number of compounds they were looking at per week. The next example I want to talk about is facilitating collaboration between sponsor organizations and contract organizations. So we were working with a customer, a large biopharmaceutical customer who leverages several different CROs, which I'm sure is not unique in the industry. What had to happen on the sponsor side is they would often get these unique data file formats from the CROs and have to spend a significant amount of time from their data scientist organization cleansing that data and getting it into a standardized file format. In this case, they were doing Excel. And inevitably, there are errors missed because this is a manual process. So what we were able to do, again, using Scientific Data Cloud, is to automatically collect these data, extract any of the relevant metadata, and then automatically standardize it. The outcomes that they saw were not only savings in time, where they could redirect those resources to more meaningful activities, but they were also seeing, orders of magnitude of change down from a couple of weeks down to a matter of minutes. The third use case I'd like to talk about is batch release. So typically what we see is a lot, again, of manual processes in the batch release and stability testing workflow. And one of the bigger problems here is not only the time, but this is a regulated workflow. And so SOPs have to be followed, and there can be transcription errors. What we're able to do with the Scientific Data Cloud is automate all of those manual steps. So we worked with a top 15 global biopharma who employed our solution for just this. By centralizing and harmonizing that data across the organization, not only did we save the time operationally in the reporting, so 8 hours weekly, but also the scientist's time for transferring files between systems. The final example I want to give is that of instrument utilization. This is normally manual data gathering and extrapolation of the how often the instruments are used. One of the benefits to having a Scientific Data Cloud is that we're able to collect that operational information as well. What you can see very quickly here is you can start to gain insights into the utilization of each type of those instruments. So we had a biotech company. They needed to increase the throughput of their sequencing workflow without having to increase the lab footprint. So with the Scientific Data Cloud, we're able to provide that visibility into the instruments enterprise-wide, not just within a single laboratory, as well as the consumables usage. And that helps to enable predictive maintenance, not because our cloud platform is doing that type of analysis, but it's surfacing the parameters that can then be trended, and being able to query that information in multiple different ways. You can increase lab productivity and efficiency, as well as reducing costs.
Now, most of these metrics are based on time, efficiency, costs. I've added one more, which is real-time monitoring and reporting for quick performance assessment, or also GMP compliance. Yeah, that is something that is sometimes difficult to measure, but I think a lot of value stands behind that.